Have you ever looked up at the night sky and just seen, a bunch of random bright dots? Well, what if I told you we could transform that whole view for you? We're going to turn that big dark canvas into a map, a time machine, and a storybook, one that's filled with ancient heroes and monsters. Let's get started.
But first, I've got a question for you. When you look up at a star, are you seeing it as it is right now, in this very moment? The wild thing is, no, not at all. You're actually looking deep, deep into the past.
It all comes down to the fact that light, even though it's the fastest thing in the universe, doesn't get here instantly. It takes thousands, sometimes millions of years for the light from those distant stars to travel all the way across space and finally hit our eyes. So really, every single star you see is like a little ghost from the past. And to even begin to measure these crazy distances, astronomers use something called a light year. Now, a lot of people think that's a measure of time, but it's not. It's all about distance. We're talking about the 9.5 trillion kilometers that light can travel in just 1 year. The scale is it's almost impossible to wrap your head around. Okay, let's put this to the test with a little thought experiment. So you've got star B, it's 30,000 light years away, and you've got star A, which is way out there at 80,000 light years away. If they were both born at the exact same time, which one would actually look older to us here on Earth? Well, think about it. We're seeing an 80,000-year-old picture of star A, but only a 30,000-year-old picture of star B. That means we're actually seeing star B 50,000 years later in its life. So somehow, the star that's closer to us, star B, is the one that looks older. All right, so we've got our heads around these mind-boggling distances. But what about the stuff we can actually see? How bright are these stars? Well, astronomers have a pretty unique way of measuring that.
The official term is apparent magnitude, and it's really just a way of describing how bright a star looks from right here on Earth. But this scale, which has been around forever, has a really weird twist.
So take a look at these two. Star A has a magnitude of +6, and star B is at +5. Which one do you think is brighter? You'd think it's the higher number, right? Nope, it's actually star B. In this ancient system, the lower the number, the brighter the star. It's totally counterintuitive.
Here's an easy way to remember it. Just think about golf. The lower your score, the better you're doing. Same thing here. But wait, it gets weirder. The scale isn't even. A difference of just one number, like from a 6 to a 5, doesn't mean it's a little bit brighter. It means that star is a whopping 2.5 times brighter.
Okay, so we've got distance and we've got brightness, but what can we actually do with the stars? Let's get practical. For centuries, sailors and explorers have used one famous star pattern to find their way. Let's find it.
Let me introduce you to Ursa Major, also known as the Great Bear. Now, tucked inside this big constellation is probably the most famous star pattern in the northern sky, the Big Dipper. This sky is basically our key to unlocking everything else.
And finding your anchor in the sky is actually super simple. First, just find that big old spoon shape of the Big Dipper. You can't miss it. Next, find the 2 stars on the outer edge of the Dipper's bowl. We call these the pointer stars. Now, just draw a line in your mind right through them and keep going up, and bam, you'll land right on the most important star for navigation up here. And that star is Polaris, the North Star. What's cool is that Polaris is also the last star and the handle of the Little Dipper, which is part of another constellation called Ursa Minor, or the Little Bear. The Big Dipper literally holds your hand and points you right to it. So why is Polaris such a big deal? Well, it's because it sits almost perfectly above the Earth's North Pole. Imagine the Earth is spinning like a top. As it spins, all the other stars seem to swirl and circle around the sky, but Polaris, it just stays put. It's the sky's pivot point, a constant, reliable beacon that has guided people for thousands of years. So once you find Polaris, hang out there for a second. Take a look around, because you're in a really cool celestial neighborhood. The constellations all around it, they're not just random shapes. They're actually the characters in one single epic story, a whole royal family drama playing out in the heavens. I mean, just look at this cast of characters all clustered right there around Polaris. We've got a king, a super vain queen, a princess in trouble, a dashing hero, and even a flying horse. They are all right there acting out this amazing story for us every single night. Let's meet the happy couple.
On the left, we've got Cepheus, the king, and on the right, you can't miss her. She looks like a big W or M in the sky. That's his wife, the queen, Cassiopeia. And her big ego is what starts all the trouble.
So here's how the drama goes down. Queen Cassiopeia brags that her daughter, Andromeda, is prettier than the sea nymphs. Big mistake. This makes the gods furious, so they send a sea monster to wreck the kingdom. The only way to stop it, they have to sacrifice their own daughter, Andromeda. But just as the monster is about to strike, our hero, Perseus, comes flying in on the winged horse Pegasus and saves the day. And as a reward, or maybe a warning, all of them were placed in the sky as constellations, forever playing out this crazy story.
What a story, right? But let's zoom in a little closer on our hero, Perseus, because in the constellation, he's carrying something a little disturbing. See, in the myth, Perseus is famous for defeating the Gorgon, Medusa, the monster with snakes for hair, whose look could turn you to stone. And in the constellation, he's actually holding her severed head. And there's one particular star in that head that has freaked people out for centuries.
That star is called Algol. To ancient stargazers, it was the winking eye of Medusa. Its ancient Hebrew name was Rosh Hasatan, which literally means Satan's head. So, why? Why such a terrifying name? Because the ancients noticed something really spooky about it. Every couple of days, the star seemed to blink.
So what's really going on up there? Is it actually a demon's eye? Well, science gives us an explanation that's frankly even cooler. Algol isn't one star. It's actually a triple star system. That blink they saw is really a tiny eclipse. It happens like clockwork every 2.87 days, when a dimmer star passes in front of the brighter one, blocking its light from our perspective. The ancients weren't seeing a demon, they were seeing orbital mechanics, and they wove it right into their stories. How amazing is that?
And speaking of things changing over time, let's circle back to our trusty North Star, Polaris. Here's one last mind-bending fact for you. Polaris hasn't always been the North Star. The Earth actually has this very slow wobble as it spins, kind of like a top that's slowing down. It's called precession. And because of it, our North Pole points to different stars over thousands of years. Back around 3000 BC, when the Egyptians were building the Great Pyramids, the North Star was a different star called Thuban in the constellation Draco the Dragon. And in about 19,000 years, it'll be Thuban again. Our constant guide in the sky isn't so constant after all.
So we've traveled across trillions of kilometers and thousands of years. We've learned how to measure the cosmos, how to find our way on our own planet, and how to read the amazing stories that our ancestors saw written in the sky. So the next time you step outside and look up, what are you going to see? Just a bunch of twinkling dots? Or are you going to see a time machine, a royal drama, and maybe even the winking eye of a demon star looking right back at you?